Hi, my name is Jamal Thorne, and I'd like to speak to you today about free stores. Before we start talking about free stores, I'd like to define a few terms. The first term is dynamic allocation, which is the allocation of memory space for a variable at runtime. The second term is static allocation, which is the allocation of memory space for a variable at compile time. The third term is pointer. A pointer is a data type whose value refers or points directly to another value stored elsewhere in the computer's memory using its address. Now, the definition of a free store is a pool of memory locations reserved for the dynamic allocation of data. I like to think of a free store as the reserved spots in a parking lot. Now, although these spots are reserved, this does not necessarily mean that they will be used. Just as in a free store. A free store reserves memory locations for dynamic allocation in the event that there needs to be dynamic memory allocation. Now, why is the free store useful? The free store is useful because in certain cases we may have an array that is dependent on whose size is dependent on the user input, such as in an emailing list. We never know how many emails we're going to get on an emailing list. Therefore, we need to be able to have that space so that we can dynamically allocate for new emails. Another reason why this is so useful is in the video game industry. Sometimes when you increase the difficulty on a video game, it increases the amount of enemies and obstacles that you encounter, and we will need to dynamically allocate memory at runtime to account for these new enemies and these new obstacles. Here we have a coding example. Now here we declare a pointer. The pointer's name is Jamal. Right now this pointer is pointing to nothing. Then we dynamically allocate a new integer and load the address of this new integer into Jamal. So this pointer Jamal is now pointing to the address where this new integer is located. Now we want to assign the value 10 to this new integer. The way that we do this is by assigning 10 to the pointer that's pointing to the address of the dynamic integer. Now here we print this 10, or the address, what's stored in the address that Jamal is pointing to, which is 10. After this, we have to delete what we are no longer using, which is so here we delete the space that the pointer Jamal is pointing to. Here's how the code works. First, we initialize a pointer Jamal. This pointer points to nothing initially. Then we dynamically allocate a new integer, and we assign its address to the pointer Jamal. So this Jamal pointer now points to the address of the new integer. Now when we assign the number 10, in order for us to assign 10 to the new integer, we have to use the pointer Jamal, which is pointing to the address. So essentially we have to put, it's going to seem as though we're putting 10 into the variable Jamal, but instead we're putting it into the address that the pointer Jamal is pointing to. Now in the grand scheme of things, the free stores and heaps contribute to making C++ and other programming languages flexible and versatile languages. They do this because they allow us to dynamically allocate and deallocate memory. They also allow for our programs to be more versatile. Free stores also contribute to this idea of memory management, which is the concept of dynamic allocation and deleting of memory. In conclusion, the free store is an area set aside for memory that is dynamically allocated. When memory is allocated dynamically, the address of this memory in the free store is loaded into a pointer. Whenever memory is allocated using the new operator, it must be deallocated using the delete operator to avoid memory leaks or garbage memory.